Hello, in this video we intuitively introduce linear systems. Linear system is an important class of systems that we deal with, especially in a circuits class. All of our circuits in a circuit class are linear circuits, so therefore they follow the linearity property of a system. So what do we mean by a linear system? We say that we have a linear system if the system satisfies the superposition principle. So what is the superposition principle? So if we have a system, and by the way, the system can be a circuit that we have in class, if the input to this system is U1 and we get an output Y1, if we have another input U2 that gives us an output Y2, we say that the system is linear if we apply a new input, U new, that is a superposition of these two inputs. If the output correspond to the same combination K1 and K2 of these two outputs, then we say that the superposition principle has been satisfied and the system is linear. Okay, so if you have input giving you an output, another input giving you another output, if you apply a new input, this is a combination of these two old inputs. If your system is linear, your output should be the same combination of the original two outputs. Okay, so now let's apply this definition to the system here. We have a system whose input is U, output is Y, and the input-output relationship is given via this equation. We would like to check either this is a linear system or not. Okay, a word of caution: a linear system doesn't mean that the equation from the input to the output follow a line. A linear system means that the system satisfies the superposition principle. So let's see. Okay, so our system input-output equation is given as y is equal to u plus 2. Now let's assume that I have an input u1. If I have an input u1, the corresponding output y1 according to this equation would be u1 plus 2. Let's assume that I have another input u2. According to the input-output equation, the output y2 should equal to u2 plus 2. Now let's feed a new input, u new. This is a combination of u1 and u2, and compute the corresponding y new. According to that equation, y new is equal to u new plus 2. Okay, now the system is linear if this y new is equal to k1 y1 plus k2 y2. So let's see. To do so, we can replace u new in terms of u1 and u2. So we can write an expression for y new as k1 u1 plus k2 u2. So I have this part plus 2. Now you ask yourself, does this equal to k1 y1 plus k2 y2, where y1 and y2 as given like that? Apparently we can write it down. So k1 y1 is equal to k1 u1 plus k1 2 plus k2 u2 plus k2 times 2. Apparently the two sides do not match and the system is not linear. So even though the input-output equation looks like a line equation, as long as we couldn't satisfy the superposition principle, this system is not linear. Now let's have another example from circuits. As I mentioned earlier, all circuits that we have in this class are linear circuits, so they satisfy the superposition naturally. So let's see that on a simple circuit that we studied, which is the voltage divider circuit. If we have this voltage divider circuit, assuming that this battery here makes our input voltage and the voltage measured at the resistor R2 is our output voltage, we can have a system input-output equation. V out is equal to R2 over R1 plus R2 Vn. Now we would like to verify that this circuit is actually a linear system. So to do so, we are going to get the output of the circuit when we have an input here V1, the output when we have an input V2, and then check the output of the circuit when we have a new output V3 that is a superposition of V1 and V2. If the corresponding output is the superposition of the two outputs coming from V1 and V2, then the circuit is linear. Okay, so let's write down the equations that we know from voltage divider circuit. V out is equal to R2 over R1 plus R2 Vn. Now we have Vn is equal to V1, so we can get V output 1. So this is V output due to input source 1. This is equal to R2 over R1 plus R2 V1. Okay, now if Vn is supplied using the source V2, so we can compute the corresponding V output due to input supply 2. This is equal to R2 over R1 plus R2 V2. Now we have a new input V3, but this V3 is special because we supply it as a superposition of V1 and V2, and we'd like to compute V out 3 and check if this is equal to V out 1 plus V out 2, because here V3 is a combination of V1 and V2. So if the system is linear, the output had to be the same combination of the output coming from 1 and the output coming from source 2. Okay, we have the equation. So V out 3, according to the equation, is equal to R2 over R1 plus R2 times V3, because the input here is V3. Now let me replace V3 using the superposition of the input. So this is equal to R2 over R1 plus R2 V1 plus V2. I can distribute this summation, so it is equal to R2 over R1 plus R2 V1 plus R2 over R1 plus R2 V2. So what you can see here, this is actually V out 1 and this is V out 2. So now this circuit, when it takes an input that is a superposition of two single inputs, the output actually is the same superposition of these two single outputs. So this circuit is a linear circuit. Now let me give you more intuition of what we have here. Okay, so when the input was V1, our circuit might look like that. This is V1 and we have R1 and we have R2 and this is V out. Same, this is V out 1. Same when the input was V2, R1, R2, and this is V out. Okay, and we did a third input V3, which is a combination of V1 plus V2, right, over the same circuit. Okay, now from our circuit experience, if I have a voltage source that is a superposition of these two sources, it can be plotted as follows. It is V1 and V2, R1 and R2. Okay, this circuit here is to obtain the output due to V3. It might look very complex for us, but if you follow the superposition principle, I can divide the circuit here into these two circuits. My input has a superposition of those two inputs. So at a time, I get the output due to V1 alone, and then I get the output due to V2 alone. Combine the two outputs together, this gives me the total output, because we have seen that when the input V3 was a superposition of V1 and V input 1 and V input 2, our output V output 3 was equal to V output 1 plus V output 2 because the circuit is linear and it satisfies the superposition principle. When the input is a superposition of two separate inputs, the output would be the same superposition of the corresponding outputs. Thank you.